Hello everyone again and welcome to the DMSI YouTube channel, and in here we're going to be exploring vectors, and specifically we're going to be looking at the skills that you need in order for you to be successful at vectors. So this here will be a part 1 particular video, and part 2 we look at the other skill that you need in order for you to be successful diving into vectors. And now, looking at what vectors is all about, we are going to look at what this video is going to offer you. The goal of this particular video here is to be able to, one, introduce you to some of the skills through analysis, and this analysis will be based on, one, diving into a specific type of triangle where this triangle has a specific space or region where this particular two lines meet to be 90 degrees, and so this here is called a right angled triangle. And this analysis is going to come across in two fronts. One particular front here focuses on what you know about the complementary angles and how complementary angles skills will enable you to determine various spaces or different particular edges on this particular triangle. These relationships are important skills to recognize, and the second one is how you're going to be effective in terms of combining these particular thoughts. One is how to determine angles and sides using Socatoa. Everyone knows this particular concept, and the other part here looks at this specific type of theorem, which is called the Pythagorean Theorem. And this Pythagorean Theorem, alongside Socatoa, do help a lot in terms of determining unknowns when it comes to triangles. Specifically for Pythagorean Theorem, we're basically looking at sides, determining sides when you're given two sides. However, for Socatoa, we're determining sides when given angles, or sometimes determining angles when given sides, or using angles and sides to determine a side. So those are the things to keep in mind when it comes to right angled triangle, and that is the goal of this particular video. The next particular video here, we're going to be looking at skills part 2, where we're going to look at triangles that are not right angled. Now, looking at this particular video here, we're going to look at analysis number 1, which is in this case case 1. And case 1 here is going to be introducing you to informations and how you're going to be able to use information to create a triangle, and from there you're going to be able to solve the triangle. And so in this particular question here, you're given a particular triangle which is labeled ABC, and in here we have our angle A to be equal to 90 degrees and our particular length of side B to be equal to 9.1 centimeters, and finally we have angle C to be 39 degrees. So given this information, how are you going to be able to determine or solve for a specific triangle, which is in this case ABC, given this information? And in order for you to do that, all you have to do is go in here and solve this particular problem. And to solve this problem, all we have to do is first draw a triangle. And so drawing a triangle, use the information given, is really a great skill to approach this particular question. And so in here, we know that this triangle has a particular angle, angle A, to be 90 degrees. Therefore, in conclusion, we can deduce that this particular triangle is a right angle triangle, where one of the angle is a 90-degree value. Once you have this given, automatically this is assigned as A, and therefore the side of A is going to be the hypotenuse, which is the longest side, because this angle is the longest angle possible for all angles in a right angle triangle. Therefore, if the longest side that is facing directly the angle here, which is A, to be the hypotenuse. Therefore, you can go either clockwise or counterclockwise depending on which particular side is longer. We know that small letter A is actually the longest side. Therefore, we can just go by saying that, hey, capital letter B, in this case, this angle here, which is, we'll call it alpha, is going to be facing this particular side here, which is small letter B. And finally, big letter C is the angle, in this case, angle C, expressed as, let's call it beta. And this is facing this side AB in terms of the line. Therefore, we're going to label this as side C, a small letter. And therefore, we are able to do our first step, which is to construct our angle. Now, the next part here says that, hey, beta, in this particular case, angle C, based on the information, is 39 degrees. Therefore, we know that this here is 39 degrees. Therefore, our new particular triangle that we'll be playing around with is going to be, in this case, since this angle tends to be really small, we are going to face our C, in this case, to be in this particular region. So we'll make this C, we'll make this A, and we're going to make this B. Therefore, this here is 39 degrees. This is our 90 degrees. This is still side A, but this here, line AB, is labeled line C, and then AC is labeled side B. We know that side A is not given, side C is not given, however, side B in here is given. And so if side B is given from this information, we can then use this and label this as that right here. So therefore, our side B is going to be labeled as, in this case, 9.1 centimeters. So we have deduced or determined our final construct, and therefore we can move further by determining our specific unknown angles. So in this case, we'll label this as angle alpha, and in here, to determine what angle alpha is, all we need to do is to determine specific concept that you know. Concept involves the following. We know that angle A plus angle B plus angle C is equal to 180 degrees, because the sum of all angles in a triangle is 180 degrees. Therefore, since we know that angle A is 90 degrees, therefore we know that the sum of angle B and angle C is also equal to 90 degrees. Therefore, we can also say that 90 degrees is equal to angle B plus angle C. Now, we know that angle C is given, which is 39 degrees. Therefore, we know that to determine angle B, all we need to do is subtract both sides by 39 degrees. Therefore, we'll be able to get our angle B to be equal to, in this case, 51 degrees. We know that angle B is the same thing as alpha, and we are able to determine our specific angle here for angle B, which is alpha, to be 51 degrees. That is step one to clarify in terms of solving this particular triangle. Now, the next step here is to find the length A and C. Now, take note that in here we need to recognize that our angle here is 51 degrees, but we need to use the given informations in order for we to find the other sides and angles that are not given. So the given information in the question is 90 degrees, we have 9.1 centimeters, and we have our angle to be 39. So in this particular case, we are going to be using this, we're going to be using this, and we are going to be using this to determine the missing things right here. That is a skill to recognize. So in order for we to find sides, let's make these a different color, to make things a little bit more, spicy a little bit. So in here, we need to find our side A and C. Now, to find sides, we need to label specific regions of this triangle. One labeling is involving the hypotenuse, which is our side for A. So we know that this is our hypotenuse. In this particular case, we are given the angle, which is 39 degrees. So the angle side that is opposite to that angle is automatically called the opposite, which is in this case labeled as C opposite. And finally, the other angle side or the other side is called the adjacent. And so once you're able to recognize this, we can then move further by recognizing that, hey, we are not going to be using Pythagorean theorem here because we are not given sides, mainly two sides. We need two sides in order for we to find the hypotenuse. In this, or if you're not given the hypotenuse, or you're not given one side but you're given the hypotenuse, either ways, as long as you're given two sides, either this or that or this, you should be able to find the unknown side. Now, take note here that even though you are able to determine the side of the other one, you should not use Pythagorean theorem because of some various, approximations that won't give you an accurate result. So that is something to keep in mind. So therefore, keeping that in mind, we are going to be choosing 39 degrees because we need that, and by so doing, we'll go to first determine what particular side is for C, what is the opposite. And to recognize that, we won't be using Pythagorean theorem, but rather we'll be using the concept known as Socatoa. And so through Socatoa, we know that, hey, in here we will be able to pick one of these three in our way to determine what C is first. And so to determine C, which is our goal, we need to look for the one that is going to be relating opposite with the given side, which is in this case our adjacent. Therefore, we'll be using tan because in here tan is the great connection that connects our theta to our specific given side, which is adjacent, and this here, which is the opposite, will be divided by the adjacent, and that will give us the angle. But in here we're given the angle, and the angle here is where theta is equal to 39 degrees. Therefore, we'll be able to determine what this particular opposite is, and also knowing that our adjacent is equal to 9.1 centimeters. Therefore, we are going to be able to determine what our opposite is by doing our specific tan of 39 degrees. Take note, we're multiplying our answer by 9.1 centimeters. And therefore, our opposite, which is in this case side C, is equal to, in this part by rounding, is approximately 7.4 centimeters. And so therefore, we're able to determine what our particular C is for the length. And so our C length is determined to be 7.4 centimeters. Now you can see that, hey, our luckily triangle in terms of labeling actually shows that, hey, one side here is in this case longer than this side, and by the scale kind of approximately that way, so we kind of got it right in here. However, for our particular hypotenuse, please still don't use Pythagorean theorem because this is an approximation. If you use an approximate value, your value for the hypotenuse will be way off. However, still stick with the Socatoa concept because you're given an angle and a side in a right angle triangle, and therefore you'll be able to deduce what the hypotenuse is. Now, since we don't know the hypotenuse, but we have adjacent given and we have an angle, therefore we'll be using this particular part here, which is chi. And so therefore chi in this case is cos theta, which is equal to our adjacent over our hypotenuse. And therefore, since we know that our angle is equal to 39 degrees, and we know that our adjacent is equal to 9.1 centimeters, then we can determine what our specific hypotenuse is. And so our hypotenuse in here is going to be the other way around. We are going to not multiply but divide, because by cross multiplying and all that fun stuff, or by dividing both sides by adjacent and then dividing both sides by cos theta, you should be able to determine what the hypotenuse is. And therefore we are going to see that, hey, 9.1 centimeters is going to be divided by our cos theta, which is in this case theta is equal to 39 degrees, and we're going to determine our hypotenuse to be equal to, drum roll, approximately 11.7 centimeters. And so our A side is given or determined to be equal to 11.7 centimeters. So in terms of analysis, we are not only able to determine angles, but also we are able to determine sides just given two angles. Well, technically one angle is a given for what type of triangle it is, but the other triangle angle and its side. Take note that Socatoa is done for right angle triangles. Number 2 points to keep in mind is that you need a side and an angle that is other than 90 degrees to be able to determine the other side using complementary angles. And then finally, using Socatoa, you can find the relationship between one angle and the given side to find two sides without using Pythagorean Theorem. And so using Socatoa, that is a great trick to use to, in order for you to be able to be successful in terms of determining sides. Take note that also by analysis, we can come to the conclusion that the bigger angle should have a longer side compared to a smaller angle which has a smaller side which is related to it in terms of how it is facing. So that is how you're able to deduce that yes, the way it is positioned based on the angles facing the side actually relates really well to what the triangle should look like. And the labeling ABC correlates how the question is designed right here. So that is it for this particular case 1. And for case 2 is given this particular triangle, I'm going to challenge you to try this particular triangle out and determine what are the things that you need to do in order for you to be successful in determining this triangle. So for case 2, you're given a triangle which is angle PQR is given in terms of the given components. One here is that we have angle Q to be equal to 90 degrees. We have our side Q to be equal to 17.4 units. And finally, we have our side R to be equal to 11.6 units. And the question here is to solve this particular triangle, which is PQR. This one is a little bit tricky, but I believe that with the right guidance and through these particular skills that we have, you should be able to determine what this particular triangle is. Now, keep in mind that there is going to be one particular skill that is going to be applied here that we didn't do here. And so that should be a given when looking at what we have done in this particular part of this particular video. So see you all on the next video, where we're going to complete this particular question, and once we complete this question, you'll be able to be fully ready, or I would say halfly ready, for what it is like to dive into vectors. So all the same, stay smart as always and believe in yourselves.